To which ships does angle of Loll apply? Angle of Loll term applies to vessels which are initially unstable, vessel, right? What is an initially unstable vessel? Vessels whose GM initial or GM0, whatever you want to call is negative. Yes or no, beta? Correct?
Yes, sir.
Now, what is this angle of Loll? Some of you would have learned something very basic which needs to be today corrected. I'm not saying what you learned was wrong. That was not precise. I would turn it that way. For entry level, that term, the definition would have served the purpose. But now, beta, if this is my ship, which is floating at a water line, being the center line here, and let's say here is the center of buoyancy. If the center of gravity is higher than meta center, this is a case of unstable vessel. Do you agree with me?
Yes, sir.
Unstable equilibrium. Why? Because kg is greater than km. Okay. Now, as long as this vessel remains exactly upright, that means not even minutest of heel or inclination, then the weight and buoyancy are in equilibrium. Why? Because if she remains vertical, if she remains upright, then through weight G, the weight is acting downwards, and through B, the buoyancy is acting upwards, which is equal to displacement, and they will balance each other and the vessel will be in equilibrium. The problem is not when she is upright. Problem is with the negative GM or unstable condition is when she does not remain upright. Now, for a ship, when you say she is upright, that is your visual estimate either by the inclinometer or the drafts forward and aft. All these methods of saying the ship is upright will give you a nearly upright ship, but there is no guarantee that the ship is exactly upright. Do you agree with me, guys?
Yes, sir.
So even when I feel my ship is upright, good. For practical purposes, she is upright, fine. But technically, she may not be upright, number one. Number two, even if your ship is absolutely upright, let's say for a moment we assume that also, ship is again at the mercy of external factors like wind and waves. And she will definitely go out from the upright condition because of these factors. Or she takes a turn, there will be heel during turn. So that will cause the inclination. So firstly, it is not possible to really say that my ship is exactly upright, number one. Two, even if you want to argue for the sake of argument that it is exactly upright, the operation of the ship will make sure, because of the external factors, turning, everything, this and that there is some inclination caused. And the moment inclination is caused, then there is a problem. What is the problem then? Problem then is this: if the ship inclines out of equilibrium, out of upright conditions, sorry, not. Now B shifts to B1 somewhere down here, and through B, I'm just taking this line slightly like this to bring the meta center down. So you have the meta center here, and you have G up. Now in this condition, what is happening is through the meta center, you have the buoyancy acting upwards. So you have the buoyancy acting upwards through the meta center like this, and through G, you have a downward weight. And what has happened is they have been transversely displaced. There is a transverse separation that has come. And as you can see, the couple that is formed, this will have a tendency to heel the ship further. And that is why this couple is called as the capsizing couple.
So
Capsizing,
can you alphabetically name that couple? What is like how
will be the capsizing lever, that will be the lever. And the moment of the couple will be called as the capsizing moment. Now this kept in, if the ship was stable, this moment would have tended to bring the ship back to upright or would have registered the further heeling of the ship. But with an unstable ship, instead of a righting moment being caused, a capsizing moment is caused, which will tend to heel the ship further. And the ship tends to heel more. That is why it is called capsizing moment, capsizing lever, capsizing couple. Now, as she heels more, one way is the ship may never be able to survive and she may just capsize. That's okay. That's one condition. Second is, if you are fortunate, depending on what is the degree of instability that you had. Now, as she heals more, this B will shift further out. As this B shifts further out, the meta center is going to move up. As the meta center moves up, what you have been told until now is that the meta center may become coincident with G. I think that's what all of you have been told until now. Correct, beta? Definition is nearly okay, not exactly okay. You see, what happens is when we say that meta center coincides with G is under an assumption that meta center moves up and down only along the center line. Meta center of a ship does not move along a center line. For a normal ship-shaped vessel, you see how the meta center moves. As the vessel heels, the meta center started from here. This was the initial meta center. And what happened? It first goes up, achieves a maxima, and then it starts coming down. This is how the meta center of a ship-shaped vessel actually nearly moves. So it has already left the center line. You can see it has already left the, it went like this and came like this. What definition you have done is the definition assuming that the meta center will move like this and go and coincide with G. Now, so meta center is unlikely to go and coincide with G. But for GZ to become zero, is it important that meta center coincides with G or something else can also make the GZ zero? If this, as she heals, this meta center leaves this place and moves up like this, and it moves like this, so it may happen at some angle. It may happen at some angle. What may happen at some angle is like this. B has shifted adequately out. I'll not draw B now. My G was here. I'm intentionally bringing it down here a little bit. My meta center was initially here, and my meta center had started moving like this. And now what has happened is there is a possibility that my meta center has come above G. Yes or no, beta? Vertically above G. Correct, beta? Through which B is acting, right? Meta center is here now.
Yes, sir.
Correct? Yes or no?
Yes, sir.
Now what has happened is M and G are again in a vertical line. The second part of this discussion today, most of the people in the exams will be, they may do the thing, but they'll remain confused as to why. Because what we are told at entry level was slightly more convenient way of just pushing the thing. Okay. So now at this angle of heel, through B, we have the upward force going up, and here is the meta center. It has come vertically above G. When meta center and G are again in a vertical line, like this case, first case, what has happened now? GZ has again become zero. Yes or no, beta? Yes or no? Because there is no transverse separation anymore. Yeah. So the correct definition of angle of Loll is when an initially unstable vessel inclines, it results into a negative or a capsizing lever. And as the vessel heels and B moves out, causing the displacement of the meta center. If you are fortunate, it's not your birthright. If you are fortunate, it may happen that before the ship is lost, It may happen that before the ship is lost, if you are lucky, you may have the metacenter again coming vertically above G and making the GZ 0. If it happens, the angle of heel theta at which this condition has been reached, this theta is called as angle of Loll. Is the concept of angle of Loll clear to everybody, guys? Is the concept of angle of Loll clear?
Yes, sir.
So we will no more say that when meta center moves and GM becomes 0, you see, all this time you were also saying GZ becomes 0. But the reason for GZ becoming 0 being given was GM has become 0. Yes or no? More. Then meta center is going to rise further up initially, and you may have positive GZ. So at angle of Loll, you may feel that vessel may give you a last minute opportunity to address your stability concerns. Now, it does not mean that angle of Loll is a very comforting situation. No, it's not a comforting situation, but it's one last opportunity probably the God gives to people who have made a mistake in assessing the stability to rectify and take correct, cautious, expeditious steps to make the vessel, to basically make the GM of the vessel positive. That means to basically bring her to stable condition from the condition of instability. So that is angle of Loll. So now angle of Loll is the angle at which for an initially unstable vessel, during the healing process, the GZ becomes 0. That angle is called as the angle of Loll. Is that clear, beta?
Correct.
Okay. Now, so I'm clearing this diagram. Let me see if I have another blank page here. Oh, no, I don't have. So I can add Y2. What is wall-sided formula for getting the GZ? It is GZ is equal to sine theta into GM initial plus half PM initial tan square theta. Okay. It is the wall-sided formula that will be used for deriving the formula for angle of Loll, and then you can learn the formula and apply. From our discussion just now, guys, and we are assuming that angle of Loll shall be reached within the wall-sided limits of the vessel, guys. So we are assuming that it will happen within the wall-sided limits of the ship. Okay. Now, at angle of Loll, what did we say? What will be the value of GZ, guys?
Zero.
What will
Zero.
zero?
Zero.
So if theta is the angle of Loll, then at angle of Loll, GZ will be 0. Correct, beta? Correct. And this expression for this GZ has two terms. One is this term and one is into this term. Okay. Now, if the result of 1 into 2 has to be 0, then guys, either 1 has to be 0 or 2 has to be 0 or both have to be 0. Yes or no? Because if A into B is 0, then either A is 0 or B is 0 or both are 0, right? Then only the result will be 0. Correct, beta? Already healed to angle of Loll. If she is healed to angle of Loll, theta will have some value. And if theta will have some value, then sine theta cannot be 0 because sine theta is 0 only for 0 degrees, right? Yes or no?
Yes, sir.
So sine
Yes,
theta
sir.
cannot be 0 for a K vessel which is already healed. Theta exists. If theta exists, sine theta cannot be 0. So that means at angle of Loll, the expression in the brackets need to be 0. That means GM initial plus half BM initial. You can write I also if you're used to, doesn't make a difference. Sine tan square theta will be 0 at angle of Loll. And in this case, keep tan theta on one side So 10 square will be equal to minus 2 GM initial upon BM initial, and for square we'll put a square root here. This becomes the formula for angle of Loll. Where theta is the angle of Loll. Is that clear, beta? So there are questions which involve use of this formula, guys. Okay. GM at angle of Loll. Now that is why I corrected your definition of GZ. Had we not corrected the definition of angle of Loll, then everybody would have said, what are you talking, sir? GM is 0. But now, having discussed the concept of angle of Loll, linking it to GZ, we all saw that G can move and come above M, and you will have a positive GM at angle of Loll. Yes or no, beta? We saw in the earlier discussion. Correct?
Yes, sir.
Okay. Now, so that is why people start arguing on this. What is this GM? GM should be 0. No, it is not so. It is because the meta center has moved, and there will be GM because meta center is not going to move only along the center line. Now, this formula, the derivation is not as simple as for angle of Loll. It's a complicated derivation. You can just remember the formula. Now, GM at angle of Loll, this is the formula, guys. GM at angle of Loll is equal to 2 into initial GM upon cos theta. Theta is the angle of Loll. In some books, you may come across like this there. That is the one and the same thing. It's up to you how you want to write it. They may have written like this, sec theta. So they're both the same, doesn't make a difference. You can use whichever you want to use. Okay, but understood? Repeated 3 times. And I don't know, may have been repeated after that also in the recent exams, but has already come 3 times. You can see this one. MV hinge ship is floating at a draft of 5.73 and 6.42 is at angle of Loll of 4 degrees. FSM 1563. Assuming the ship to be wall-sided, calculate her kg. Guys, can we quickly get the height draft first, guys? Please get the height draft.
79.8.
79.6, is it?
8.5.
8.
8.5.
Okay, KB.
KB sir 3.241.
3.241.
Okay, KM beta.
8.442.
8.418. 88.
49. 419.
419.
419, okay.
3 digits sir.
Okay, 419, okay. Theta this time. So what do we know? This formula can be written like this: tan square theta is equal to minus 2 GM initial upon BM initial. Sorry, I forgot to put minus here. So you can put the minus, right? Okay, so now we know the theta. BM, what will be BM equal to? BM will be equal to KM minus KB.
5.178.
5.178. Now we go to the expression. The angle of Loll is 4 degrees. So tan square 4 degrees. So tan 4 square, right, will be equal to minus 2 into GM initial divided by BM 5.178. Can you please calculate the GM initial with this formula now, beta?
0.013 negative.
0. Okay, negative 0.013. Can somebody validate it?
Yes sir, correct.
Yes,
Okay.
0.013.
Question wants kg. Okay. Now kg will be solid kg. So what do we have? This will be GM fluid. To make GM fluid into GM solid, we will add FSC. So
Yes, sir.
calculate the FSC. FSM is given.
1.128.
1 point, is it? 1.1.
0.128.
0.128.
Yeah, okay, 0.128. This will give us GM initial solid beta, which will be equal to now plus 5.
0.115 positive.
0.115 positive, right?
Yes,
This
sir.
is our G. Km initial is 8.419, and this gives us the kg of the
8.3.
ship. Yeah, so that is the
8.3.
answer. That is the answer to the question, guys. This formula we are talking about, guys. List when the initial metacentric height is 0. Now you'll say, why are we talking about it? Because the formula of list that you have been using all this while is this one: tan theta is equal to GG1 transverse upon GM initial. Now if GM, which is in the denominator, becomes 0, then this expression becomes infinity or is not defined. Yes or no, beta? With numerator denominator being 0, correct?
Yes, sir.
So therefore, you cannot use this formula which you have been using all this while if the initial metacentric height of the vessel is 0 and there are weight shifted causing the list. Okay. Now, basically, it is again the use of wall-sided formula. I can quickly take you through because it's a simple one. The simple ones I don't mind taking through, like the GM at angle of Loll is little complicated with integration and stuff. So if somebody wants, I can send you the photo of the derivation. It's not an issue. It's lying in my drawer in the office. Okay. Now here is the ship beta whose initial GM is 0. Okay. And now when we shift away W through a transverse distance D, this will cause the vessel to list. So what will happen? The deck will incline like this. And what will it do? It will cause the G of the ship to shift parallel to this to G1. Okay. And this will cause the vessel to list. Has shifted parallel to the deck like this through a distance T, causing the G of the ship, water line can be anywhere, doesn't make a difference, causing the G of the ship to shift parallel to the deck. So GG1 is parallel to the deck of the ship. And now in this condition, you have the B shifted below G1, and this is the angle of list caused because of the shifting of the weight. Okay, this angle obviously is 90 degrees. That GG1 is parallel to deck, means perpendicular to the center line. Now in this equilibrium condition, what is balancing the listing moment, guys? What is putting the listing moment in the equilibrium? First tell me, what is the listing moment? Listing moment usually you say is W into D, correct? Now to derive a simplified formula, we are talking in terms of equilibrium condition like we spoke when we were talking about angle of heel during turning. I'm not talking of the initial diagram. I'm talking of when the ship has reached an equilibrium and listed to a certain angle theta. So we are talking about this diagram now. In the second diagram, when the equilibrium is reached, guys, what is the listing moment here? This will be the angle when the listing moment becomes equal to the righting moment, correct? Yes or no? Correct, beta? Correct? This green line, the center line, and the deck are perpendicular to each other. The two blue lines which are marked are perpendicular to each other. This is angle is between the green and the blue line here, theta. So whatever is the angle between them, same would be the angle between their perpendiculars here. That is why this angle is also theta. Now, what am I saying? The vessel in the equilibrium condition, that means in the second diagram, what is the horizontal distance? Horizontal means parallel to the water line. What is the horizontal distance separating or through which the weight has been shifted? The horizontal distance through which weight has been shifted is this distance. And what is this distance equal to? This distance is equal to d cos theta. That means the horizontal distance in the condition of equilibrium. If you see in the upright condition, then the listing moment is W into D, absolutely. But that listing moment also gradually keeps reducing. And in the equilibrium condition, this will reduce to D into cos theta. How much will be the reduction? You may say if she has listed 5 degrees, cos 5 is nearly 1. So there's no difference, but yes, theoretically there will be a difference. So d cos theta is the listing lever, in the equilibrium condition. So what I'm saying is listing moment in equilibrium condition is the weight that is shifted W into d cos theta. Beta, any questions on this? Listing moment in the equilibrium condition is small w into d cos theta, correct? Correct, beta? Be equal to w into gz. Usually, what do you take gz as? Gm sine theta. But in this case, the initial gm is already 0. So that means gm sine theta formula will not fit in. So how do I get gz? I use the gz by the wall-sided formula, which we just did. So what does the writing moment become? It becomes W into GZ is by wall-sided formula sine theta into GM initial plus half PM initial tan square theta. Does everybody agree with this wall-sided formula? We used it for angle of Loll also, correct, beta? That's why both the questions are in at one place, because both are using the wall-sided formula. Out of this GM is already 0 known to us. GM initial is 0 in the given condition. So the writing moment becomes equal to W into sine theta into 1 by 2 dm initial tan square theta. This is what the writing moment is equal to by wall-sided formula. Okay. As the vessel is in equilibrium at angle of list, the listing moment and the writing moment become equal. So what does it become? The writing moment of W into sine theta into 1 by 2 Bm tan square theta becomes equal to the listing moment of small w into d cos theta. If I bring the cos theta to the left, then this sine and this cos makes another tan. It becomes tan cube theta on the left side. I retain tan cube on the left side and take everything else to the right side. So what is left on the right side is this 2 will go in the numerator. 2 into w into d. Cos theta has already come to left. And we'll have the w going down here. We'll have the bm going down here. Correct, Peter? This becomes the formula, or we can say tan theta is equal to cube root of, it's not the square root, it's cube root of 2 into w into d upon w into bm initial. This becomes the formula for finding the list of the ship which has initial metacentric height, which is 0. So what you need to, if you have understood the derivation, good enough. If you have not understood the derivation, never mind. Please remember that if the initial metacentric height is 0, then to calculate the list, you'll have to take the cube root of 2 into w into d upon w into bm. Can you take down the formula, guys?